All right, cool. I reckon we can probably get started then. So welcome everyone to our latest version of the Neo4j online meetup. So we've got Pat with us today from StreamSets. So he's going to be showing us how to use StreamSets to get Salesforce data into Neo4j and how to query it. With that, I guess we'll do our round of introductions first. So we've got. So my name is Mark. So I work on the developer relations team at Neo. We've also got Michael. Michael, let you introduce yourself as well.
Yeah, so I'm Michael. I'm the leading the developer relations team for Neo4j, and happy to help all people that want to get graph data going in their applications and in the research and use cases. And we're having some really cool stuff going on, and so I'm really excited when people like Pat just ping us on Twitter and say, "Look what we've built," and then you look at it and you say, "Wow, it's much better than we could have done it." So it's really cool to see people all around the world, integrating and connecting to Neo and building really cool stuff and integration. So happy to have you here, Pat. Really cool.
Cool. And so then, I guess that leaves you, Pat. So welcome.
Yeah, thanks. So I'm Pat Patterson. I'm the community champion for StreamSets. So that means I get to write a little bit of code and write blog entries and present at conferences and do online webinars and I get all the fun stuff. It's great.
Cool. So I've shared the blog post that you wrote about using StreamSets with Salesforce and Neo. So maybe for everyone who hasn't read it yet, you could give maybe a quick overview. What is StreamSets and what were you using it for?
Yeah, let me share my screen because I've got a couple of slides that will probably help illustrate it. Let's go to the right one here. Okay, so that's my Twitter. So yeah, if you want to fuel my personality cult, I'm Metadaddy on Twitter, and I kind of tweet about StreamSets and the fun things we do about it. There's a little taster there on this morning stuff. Just a little bit of context on StreamSets. I don't want to do like a huge pitch or an ad or anything, but StreamSets was founded a couple of years ago by our founders were from Cloudera and Informatica, and they could see that the existing ETL tools didn't work very well for this new world of big data and NoSQL. And this kind of huge variety of data sources and stores we have now, and the idea of continuous data in motion. So they founded StreamSets in, I think, 2015. I know that came out of stealth in September 2015. And we've got people from, I'm from Salesforce, we've got people from Elastic, Square, and so on. A lot of our engineers are Apache committers, contributors, PMCs. The open source ethic runs strong within StreamSets. The data collector that I built this with is Apache 2 license. And we've got customers all across different industries, so automotive, banking, insurance, all over the place. And just on the bottom right, we've had over 200,000 downloads. You can just go download Data Collector. And, my job is to kind of get some insight into who's using it and who's downloading it. We estimate about half of the Fortune 100. So half of the biggest 100 companies in the world have downloaded StreamSets. And, why don't I just kind of dive in? So what I did was I built a pipeline for reading data from Salesforce. So if you're not familiar with Salesforce, it's basically an online service for managing customers and like your interactions with customers, like the deals that you've got in play, and also support cases. So what I have here, like this is like the Salesforce Developer Edition. Probably zooming in would be a little more useful here. So here's a support case that, this is just dummy data that you get when you create a Salesforce developer environment. And some account called Edge Communications, and they had a problem with a generator. And you can see that, it's fairly standard enterprisey kind of stuff. This is actually the old Salesforce environment. There's a newer UI called Lightning, but I just use this because I'm used to it. But I can see here that the data is pretty rich here. So this case refers to an account. So I can kind of click through to that and get all the details on this Edge Communications account. And the case is related to a contact. So there's a particular person that I'm talking to about this generator problem. And similarly, I've got this account Edge Communications, and from there I can see the contacts and the cases and also the opportunities. So this is like repeat business I might have with this customer. So here I've got a deal for an emergency generator, and I expect to get $21,000 from that. So, this is very, very widely used. Salesforce is pretty much the de facto customer relationship management system now. So I figured it would be kind of interesting to pick up this data and pull it into Neo4j and try and visualize its structure, see if we could do some analysis, see what conclusions we could draw. And that's where StreamSets comes in.
Hey, Pat, so just a quick question. Was there anything in particular about the data when you were looking at that screamed out to you, I should try and put this in a graph? Was it just a hunch, or what made you decide to try?
The interesting thing is there's kind of two sides of Salesforce. There's there's more than two sides nowadays, but you've got the Salesforce automation side, which is this tracking the opportunities. This idea of I'm so many percent, 60% sure of getting this deal, so my expected revenue is 21,000 out of the total 35,000. That's like the Salesforce automation side, and then there's this service side, what they call the Service Cloud, which is the cases, and they're kind of joined on this account. But the idea I had was, okay, this data is all kind of linked, and this seemed to map well to the graph database idea of I've got nodes which are accounts and cases, and I've got the edges showing the relationship, and just the idea of to better serve these customers, can I explore this data and maybe see connections and do some kind of ad hoc queries that I can't easily do from from here as a Salesforce user. So let's have a little look. So here I've got like the very, very basic pipeline that I wrote. And the idea here is I can read data from many, many different sources. So let's zoom in a little bit here as well. So here I've got a whole bunch of origins. This is just a few. These are just the ones I happen to have installed. But I could read from a relational database, Salesforce, got different kinds of servers here, HTTP server, a CoAP server. And in fact, I've got like a core system with a couple of extensions installed. But we could read from RabbitMQ, Redis, MapR, MongoDB, Elastic, you name it, we can read data. And this makes it like this a very, very flexible tool. So I've got my connection to Salesforce. I'm not going to reveal my username and password. I'm loading those from resource files. And I've got a query. So this is actually like a pretty kind of rich kind of query. I'm querying these cases, so support cases, and I'm following a bunch of relationships. So this is Salesforce's query language. So SOQL instead of SQL, Salesforce Object Query Language. And I can't do arbitrary joins, but I can follow these relationships. So I can say for a case, I can get its ID, its case number, and so on. But I can also follow these relationships. So I can go to the account associated with the case and get its name, and then go to the contact and get the name, and so on. And so I can pull all of this data out of Salesforce. And the nice thing here is I can actually do a little preview and get an idea of the shape of this data, before I push it into Neo4j, because it helps to get an idea of what you're actually playing with. So let's make that big. And I can see here for this case, this is the one we just looked at, starting generator after electrical failure. I get a little hierarchy of data back. So I get the account and the account name, Edge Communications. I get the contact name, Rose Gonzalez. And then I'm navigating background to the account for there, because usually they'll be the same, but you never know. This is one of the things that this analysis might tell you. You might have a contact that happens to be in a different account from the support case. So I kind of got that little bit of redundant information in this case. But this preview lets me pull all that without actually sending it anywhere. And then the Neo4j side, this is pretty neat. I come out of preview here. I have what's called a JDBC executor, and this is like a general purpose connector. And the really nice thing is that I can put in my connection string and my credentials here. Again, I'm just reading them from files, so I don't reveal them to the world. And I can put in arbitrary SQL. I can just literally specify the query. And of course, in this case, we're dealing with Neo4j. So it's Cypher. And I want to give a shout out to Michael here, because he actually helped. I did a version of this that was a bit dodgy. And, he taught me about onCreate set and how to do things properly, so that I'm properly doing this, merging on the ID and setting all the other attributes, so I can run this multiple times and I don't get duplicates and all that good stuff. But this is, if you've done Neo4j, this is probably pretty basic stuff. I'm creating, for each case, I'm using this merge to create a node, and I'm using the ID from the record in Salesforce. So, fortunately, Salesforce has a unique ID for every single record. So that makes our life really easy here. And then when I actually create one of these things, I'm setting all these attributes. So case number, status, subject, and so on. And then the really nice thing here is that this one query is bringing me back this whole hierarchy of data, and I can model this directly by just creating an account with the account ID and a contact with the contact ID. And then if we go down here, I can create the relationships. So this is, for me, coming to Neo4j, like backing up a little, I actually used Neo4j in Coursera big data specialization. So they had a whole course about graph database where Neo4j was the teaching medium, I guess. So I'd learned a little bit of this, and this was pretty awesome to be able to just say, okay, created these nodes, let's create these edges, these relationships between them. And I guess the thing to do now is to just run this, and we'll see it actually in Neo4j. So
just to check one thing.
Yeah.
So does that query run one time for each row or record that comes back from the Salesforce query that we looked at before?
Yes, it does. Yeah, exactly.
Cool.
So this is run on a record by record basis, and then over on the advanced tab, you can enable auto commit. So commit after each statement, but it's more efficient to commit after the batch. So what it's going to do is it's going to read. This is just a test system, so it's only got like a small amount of data. So it's going to read all the data, run all those Cypher statements, and then do the commit. So it's pretty efficient. If I had like thousands and thousands of rows in the default configuration, I'd read them 1,000 at a time, and run 1,000 of those sets of statements, and then do the commit. So we can do it. We can do this very, very efficiently. So yeah, so let's run it. And this really takes almost no time. It's kind of starts up, gets its libraries together, and then it'll stop almost immediately. And in the history here, I can see that we read in 26 cases and wrote out 26. There were no errors. So this bar here is empty. And that took about 8 seconds. And let's go look in Neo4j. So with a bit of luck, there's my graph. And so, you know, we can start to see a little bit of the shape of this thing. This is the cases. So the cases are in, let's see, green. So I can see cases here, and I can see very easily these products are in yellow. I can see very easily, you know, which products have got the most cases associated with them. You know, I could obviously run it like, you know, some kind of query to do that, but this kind of gives me a nice way of visually manipulating the data. I can see this United Oil and Gas Corporation is kind of like a nexus here. Now, things become really, really interesting when I run my second pipeline to get the opportunities. So this just does exactly the same thing, but this time I'm reading opportunity data. So remember, this is the deals in play with the accounts. And again, I'm writing them almost the same kind of stuff, writing them to Neo4j. Now, the really neat thing here is I'm merging these accounts. So I'm like literally merging the opportunity side into the sales side. So if I run this one, and again, it just takes just a handful of seconds. Almost as soon as it says running, it decides, okay, I'm done. And we'll just have a quick check here. So this time I've got 31 opportunities, and then go over and I don't know if you can magically refresh, but this is the way I do it. So we can see we've got much more data this time, and we can actually see if we zoom out. I mean, this is really nice because I have these disconnected islands where these are new customers. So customers, like these accounts that are purple with opportunities that are gray. So these are deals with new customers. And I can also see this activity around these real busy customers where they have cases and opportunities. And I can start writing Cypher queries. So let me find. So I happen to have one. I
guess one thing we haven't talked about yet was how did you come up with your model? Did you just replicate what the Salesforce structure looked like, or were there any tweaks from that?
No, this is really just a straightforward mapping of the Salesforce data model. You know, accounts. If I go over here, a case is associated with a single account. And an account, you know, has, you know, 0 or many cases, 0 or many opportunities. So this was really, a straightforward one-to-one mapping. You could get kind of clever with this, but you know, I kind of had in mind what I wanted to do, and I can run my arbitrary Cypher queries. So here, what I'm wanting to say is, I want to find all new cases, so you know, cases that haven't started being worked, and which accounts they're associated with. So I always do that, hit return instead of play. So you know, I get this data out very easily. I could see there's 2 accounts, and there's like 3 associated cases. So that's really basic stuff. I can do some nice kind of analytics here. So find closed cases and kind of get a table of accounts and their closed cases. So if I go, that's a better view. So I can see United Oil and Gas, I've got 5 closed cases, Grand Hotels 4, and so on. So I can do some nice analytics. And I can also do things like, where's a really nice one here? I've got a whole cheat sheet of these. So accounts with open cases, let's see, we'll unpack this one. So this was like the granddaddy for me. This was joining this data together. So you can see here, like everything hinges on the account. So I'm wanting to get cases where their status is not closed. So open cases, so, you know, problems that are active right now. associated with accounts, and I want to get the sum of the expected revenue for those accounts. So who do I have the most money up in the air in, maybe renewals or future deals that has got these companies have got ongoing problems. So, this is really nice because this is like customer service thing. I can see, United Oil and Gas here have $5.5 million in expected revenue, and they have open cases. So GenePoint have 151,000. So that lets me, like, if I was the support manager or whatever, that would let me really target my efforts and say, these United Oil and Gas guys have got $5.5 million on the table with us, and they've still got open tickets. We ought to go and shut those down and make them a happy customer, so we get their renewal or whatever. So yeah, that's kind of the loop I came around to with this. And the really cool thing, I mean, I've used Salesforce here just because I used to work there and I know the model very well. I know the data, but I could have done this with any data source. I could have used CSV data or a relational database, or even like pulling data from Kafka and adding it to Neo4j dynamically.
Yeah, that's the really nice bit, that you can actually, in the graph model, because as soon as you have one connection point, you can bring data from many different data sources together. And you could, for instance, if you have like Zendesk or something like that for case management as well, you can pull in like the support texts and so on. And then perhaps even use something like natural language processing with Neo4j to kind of get more insights into what's the content of these cases. Is there actually some kind of tagging for these cases? Kind of what categories? You mentioned that they have categories, right?
Yeah. So here, the data I'm bringing back is the status, so closed, whatever. There's a text description. It's just empty for this one. The priority, there's an is closed flag. Let's see if there's anything. Oh yeah, subject, performance inadequate for second consecutive week. So yeah, I've brought back kind of a sample of the fields here. But yeah, you could bring back everything that's in the source database. Like here, I guess the key ones here are things like priority and status. And you could do natural language processing on the subject, on this kind of text content here.
Yeah, what's interesting is we could even enrich this data set and saying, for instance, we turn, for instance, the status into an additional label for the case. So we could also just visualize them by label to see if they have different status values. And then the other thing that I thought about could be interesting is if you have like the time information, we could also turn them into like a linked list of this case came before, this case came before this case.
Right.
So you see also like a progression of cases from this customer. I have a technical question. Could you show how you integrated the JDBC driver, so the jar with StreamSets, so that people know where they would have to put it, and what's like the configuration that you have to do?
Sure. So that's a great question, because this is like an area that is often a stumbling block. So so here's like the StreamSets homepage, if you like. So those are my pipelines. So what I had to do was up here, this is our package manager, the little kind of, I guess it's supposed to be like a present in a box. So here we can see here the stage libraries. So these are the available connectors for StreamSets. So I've got Kafka and Kudu, Solr. So you can see I've got the basic one that comes pre-installed. And what I had to do was I had to install the JDBC stage library. So you would do that just by clicking there and then doing plus, but I can't do it because it's already installed. And same for the Salesforce one. But if I wanted Redis, I would like tick that one and press plus there.
So does it go and download these from the internet somewhere, does it? Or?
Yeah, that's exactly. Yeah, exactly. So if I do plus there,
StreamSets
gonna-
App Store or something.
yeah, we've got like an archive online, so I can install from that, and then it'll install it, and then it says, okay, do you want to restart? But okay, I don't, because that just locked me out for about 15 seconds. So yeah, next time I restart, that Redis library is going to be available. Now, of course, if we install JDBC, that's kind of our half of the equation. You also have to install the particular JDBC driver for the database you're talking to. So in this external libraries, that's where you can install your JDBC drivers. So here, you click this thing here, and then you browse for the library. And so let's put in Oracle as well. I already put in Neo4j. So I just choose the Oracle jar and say upload. And again, it's going to say, okay, you've got to restart this before you can use it, because it's got to kind of load the jars and everything, but it's there in the list. And yeah, from that point, then you can, if I go back to my cases pipeline, you've really just got to make sure that you, in the JDBC thing, you get the right connection string here. Occasionally, if you've got a whole bunch of JDBC drivers, the loader seems to get a little bit confused. So we do have this facility for putting in the driver class name. So you can, if you get some weird error when you try and run this, and it says, oh, can't load driver class library or something like that, you can just specify com.neo4j, whatever the JDBC driver class is there, and that just kind of specifies it directly rather than searching the loaded jars from the JDBC connection string. But most of the time, this, like, my current configuration, this just works, and I just, as long as I specify the correct Neo4j bolt URL here, and my Neo4j is on localhost, it just works.
Cool. Michael and I were talking before. So what would be the advantage of having like for example, if you had a custom Neo4j connector as opposed to using JDBC, would there be anything you'd get extra from doing that?
Yeah.
And how would you build it would be my second question to that. So how would you build a connector?
Right. I mean, that's a great question. And, it goes to the heart of this inherent trade-off with, we can use an off-the-shelf JDBC driver. Usually that's a little less efficient, because you're going through these layers of calls and protocol and so on to get down to the actual database interaction. I mean, it works well, but you could write a custom connector, a custom destination, or even an origin that was able to directly use the Java client library. So I've done this a couple of times, actually. We've got some tutorials on this exact topic. So writing custom stages. So I did one for writing batches of records to a simple webhook. So I show step by step. You just run a Maven archetype. You can build the template from a Maven archetype, and then I kind of run through step by step here. So this is if you wanted to write a custom destination to write to Neo4j. Yeah. Really, it gets down to, this is the core of the code here. You're implementing this method to write a batch of records. So you just kind of iterate through, and here we just call this write for a single record, and then this is the template one. And if I go down a bit, I'll show you what I do for writing. I just wrote to request bin for this. This is a test to show how this would work. So scroll down. Do I have the final code? Yeah, here I'm posting data to an endpoint. So yeah, you could just I think I format up the CSV data and then post it off, and it's kind of all step by step here. I don't think I've got the whole thing, but oh, here we go. Yeah, so when I'm writing a batch of records, I generate CSV data and kind of build up this string, and then I can post it off once per batch. So here would be where you would make API calls in Neo4j.
Cool.
So would you say the people using like writing this type of thing, would this be people who would be, maybe the title would be data engineer? Is that, I think would that be the type of person? Is it data scientist, or who do you find that would be the person, I guess, using string sets and implementing, say, one of these custom
right. So using stream sets like from this side, we actually surveyed our community, and yeah, the most common job title or self description was data engineer, and then data scientist, and then developer. So it's very much, there are people whose job it is to wrangle the data from where it's being created to where it needs to be analyzed. So really, like this view of things is very much the kind of data engineer, data scientist. Now, we do have people in the community who tend to work for consultancies and system integrators who are doing more of this kind of thing, like the custom work. They tend to be more developer, data engineer, less data scientist. They're comfortable with Java and so on. So we've got, like, one guy in South Africa wrote a Couchbase destination to write data directly into Couchbase. But there's a kind of like a halfway house in that I can do things like have where is it now? I can have Groovy or JavaScript like in my pipeline. So if I needed, I could do a whole bunch of transformation between the origin and destination, just with these like flattening out hierarchies and masking fields, pivoting. So if I've got a list of data within one record, I can turn it into a whole bunch of records, removing fields. I can do a whole bunch, just dragging these processes onto the pipeline. So like if I wanted to remove some fields for whatever reason, and then, if I'm doing something really custom, I can just run some JavaScript, Groovy, or Python actually on the records. So here I've got a whole bunch of comments here. This is just the standard template, but you iterate through the records in a batch, and you can do all kinds of manipulation, ultimately like writing the records. So you're receiving records from one side and writing them to the other. So you can do fun things in here. I think our tutorial shows you how to look at credit card numbers and figure out whether it's Visa, MasterCard, or American Express from the card number, which is something you can do in a few lines of code. But you can't really do it with these kind of more basic transformations.
For these script evaluators, can they use external libraries, or are they kind of limited to what the language offers in terms of what's available?
Yeah, you can, in fact. So you can use, so it's all loaded. So backing up a little bit, StreamSets is a Java application. Okay, it has this stateless UI. So this UI is just using our REST API to interact with the app. And we load these scripts through JSR 223, I think it is, the Java scripting interface. And so they can have access to any jar files. So you can basically make jar files available to them. So I did a blog entry showing how you could do a SHA-3 hash from one of these scripts by loading the Bounty Castle crypto jar files. And you can load external libraries in the particular language. So for JavaScript, I've done a blog entry showing how to load like external JavaScript modules. Groovy is easy because Groovy is basically just jar files. Groovy's got a tight integration with Java. And for Python, we actually use Jython. And so any pure Python libraries will just work. Often where you're going down to like a Python C library, there's often a Jython equivalent. So there's, say, the element tree XML handling is built into Jython. But yeah, in general, you can use external libraries. We can also do Scala. We can run Scala in an embedded Spark engine, and you can have some real fun there because you can have multi-threading within your Scala evaluator.
So I think with the pipeline you showed before, you've ran it manually. Could you have it like hooked up so that it detected events from Salesforce or from other producers?
So yeah, absolutely. So if let me just get rid of this evaluator thing here. Yeah, so the way these things are designed to work is continuously. So like this is kind of like a special case. I just set it up to never repeat. Now, in general cases with like a lot of databases, you can run incremental queries where you can run the same query, but we remember this offset. So like here, the ID is like this offset field. So every time you run this, it'll substitute the last ID you saw in there. So it would get like new cases that were being created. And that works with JDBC and so on. Salesforce has a streaming API where you can get notifications. So I can check that, subscribe for notifications. And if I have things set up on the Salesforce side, I could have, it's like a subscription topic kind of thing. So if I had set it up on Salesforce side, I could say, get case updates. And in fact, if I try that now, it's going to rightly say, hey, case updates doesn't exist. But I could go into the Salesforce side and say, okay, I want this case updates topic. And every time a new case is created or anything changes on that case, that's going to, like while this pipeline is running, it's going to get a notification. And the key thing there would be in this cipher, I'd have to have the, what's the other one? You have on create and on
match.
On match, yeah.
Yeah.
So yeah, on match, I would have to have a similar thing. So you can imagine I could get updates where the status changed. So maybe the case was closed. I could be receiving those updates as the pipeline's running, and it would do on match, and it would set the new status. So I think actually the on match would be just a duplicate of this. Can you say on create comma match, or do you have to just duplicate the whole thing?
Yeah, so there's three of them. So there's set on its own, which will run regardless of whether the merge matches or create, and then there's on create, which you're using obviously, and then there's on match. So if the property changes need to happen regardless if it was on match or on create, you could just delete the on create bit and just do it all the time.
Do like that?
Yeah, exactly.
Oh, cool. Okay, yeah, because that's what you would want to do, because like this thing, the ID is never going to change. And these are all dynamic. So yeah, you would always want to kind of find the node or create it based on that ID. And then this stuff all comes along for the ride. So yeah, if I had 5 minutes offline here, I could go into Salesforce and create this case updates topic and come back and then just run this, and we could show it all changing. But it's not a very interesting 2 or 3 minutes for the viewers as I futz around with Salesforce code.
Yeah, just something I was thinking of. So you've got, at the moment, you've got JDBC on one side. If you had some data in, say, a MySQL or Postgres database, could you have a JDBC as the origin and as the destination?
Oh yeah,
functionality?
yeah,
Cool.
absolutely, yeah. And I've done things like read from one Salesforce environment and written to another, where you want to do some like synchronization across. Yeah, I mean you can get into some interesting situations by reading and writing from the same data source and getting to endless loops. But no, I mean this whole thing is designed to be any to any. So you could the one kind of architectural point here is that a pipeline has a single origin, so you can't kind of merge within a pipeline. But just to, like, here I've got these two pipelines, both going into the same Neo4j, because one of them's grabbing cases, one of them's grabbing opportunities. You can do the same thing. So I could have I could read from Salesforce, Zendesk, and MySQL, and feed into Neo4j. And as long as you've got some, common key to use for that, for your, like your node ID or whatever, then it's all going to work out. But I guess, I mean, even if you if you had different keys in different systems, as long as they're on the node, like the different pipelines could use different fields to merge, right?
Yep.
Yeah. So that's an interesting one. So you could have these cases, like they're like master. Sorry, I'm clicking badly here. So like their master unique ID is this ID field, but they also have case number. So if you had, say, Zendesk, or, well, Zendesk isn't a good example. So maybe you have MySQL that you were doing some support case work, and it was using case number. Then a second pipeline might say merge on case number and put a bunch of different attributes into Neo4j.
Oh, okay, yeah. So if you've got like the same type in a different system,
right? Yeah, as long as you've got some unique key on the node.
Yeah.
And there's no reason the node can't have multiple unique keys. In practice, like this is unique and this is unique. So
yeah, I don't know what would be the best way to model that, because you could do like you said and just have all the properties on one node. Something I've played around with before is like having like maybe like a really sparse node representing the actual case, and then more populated nodes coming off it that represent the data that comes from each of the systems. So you could have like a central case node that just has the ID, right, and then one with all the stuff from MySQL, and another one with the
got it. Yeah,
so
stuff
from Salesforce, for example.
Right. Yeah. So more kind of separated out, almost like a snowflake kind of structure, fact table and dimensions and that kind of stuff.
So that tends to be more where, like if you're pulling in, like an obvious one would be lots of different accounts that are the same person but come from different systems.
Right.
And you might want to keep them separated because maybe they duplicate the name, and you're like, I want to.
Right.
And that type of thing.
Oh, I see. Okay. So but they'd be linked. They'd be linked together. So you see them as like little clusters like this, but they would be like you would see like they're conceptually like this whole cluster would be the same real world person, but the different nodes would show you the different records in different locations. Yeah,
exactly. Yeah, and then it would make the model a bit more complicated. But the nice thing would be that you kind of have your lineage of where the data came from if you ever wanted to go and and check rather.
And incidentally, that's something we can do here because we have, if I go into preview again and show the headers. So when you read from, I've broken something now. Okay, this is the always the trouble with demo. You start clicking around and changing things, and then you break your system. So so a nice example here is, you can have like all these pipelines shuffling data around, and like here it has the lineage here because you have the query that was used and the object in Salesforce it came from.
Oh, cool.
So these are in the header, but you can easily kind of move these into record fields. And this is what some customers do. So they're reading from relational database tables or even text files, and they want that lineage information to actually accompany the data. So they basically just move the metadata into record fields, and that goes along, is written out to the Hive or wherever they're ultimately writing the data, so that you can basically then pinpoint, oh, this is where this record ultimately arose.
Cool.
All right.
Yeah. So the only comments we've got from the chat are that are from Diana, saying she really likes the way that you can use Neo like this to do analytics queries and connect it with StreamSets and ODBC. Otherwise, everyone is very quiet.
All right. We've either bludgeoned them to death, or we've completely satisfied their every question.
So do you find, like, if someone was using this, what would be would they run it on their machine? Would you put it what would you go and deploy it somewhere, or what would be the typical setup if you had multiple people working?
So
on StreamSets?
Yeah. So typically the data collector, it can run like as a standalone process. So here we're reading from Salesforce. We can just run on one box doing that. If you're reading from, say, Hadoop, we can actually run in a Hadoop cluster. So it runs as a MapReduce job. We can run
really well. Cool.
We can run on a Spark cluster. So if you're reading from Kafka, as many partitions as Kafka has, you have that many instances running in Spark. So we can run in the cluster in that kind of way. Mm-hmm. We actually have a second product called Dataflow Performance Manager. Some of our customers have hundreds or even thousands of these pipelines running, and Dataflow Performance Manager gives you a way to visualize the system kind of end to end. And let me go to its page, and it gives you also a repository for pipelines with versioning. So when you've got multiple designers and a whole bunch of data flows. Here, this in this picture here, each of these green gears is one of those pipelines. So one pipeline reads web logs, writes into Kafka, another one reads from Kafka, writes into Hadoop, and so on. And each of these is kind of in a repository, so you can say, okay, run this pipeline on that node, that instance, and they all report back their statistics. So you can get this idea of throughput and latency, and you can start setting SLAs to say, okay, well, there could be a maximum of 1 second between data being produced here and arriving here, and I need an alert if it goes above 750 milliseconds. So this is really we sell this as a service. This is like really the kind of enterprise management side of it. This is where data collector is for your data engineers, data scientists, developers. Yeah. This is for your operations people who are tasked with keeping this thing going 24/7.
And so does this run like on its own and then monitors either Spark or Hadoop, or is this also deployed inside that Hadoop Spark cluster?
So this is run like as a service. So we run it in our cloud, and then like these things report their statistics back to DPM. So they're calling in periodically to say, hey, I just processed another 100,000 records. So you get this kind of dashboard view. But we have customers running this. So one of our customers, Cox Automotive, has 25 subsidiaries, all working with different aspects of the car ownership lifecycle. So autotrader.com, so car ads and so on. Yeah. Kelley Blue Book, which is like car valuations, et cetera, et cetera. And they have pipelines in each subsidiary reading all the data out of Oracle or wherever, writing it to their central data lake, which is on Hive, and they have a pipeline in each subsidiary writing into Kafka, and then a central cluster of pipelines reading from Kafka, and they're processing hundreds of millions of records and doing some pretty neat. So we haven't even got into the neat stuff we can do with changing the schema in Hive dynamically as the data changes, and they have their pipelines running for weeks at a time, just continuously.
We've got a couple of questions now for you, going back a bit from where I've taken our conversation. So, first one is, how long do you think it would take someone to set up something similar to your Salesforce Neo4j example?
So what I would recommend is in our documentation, there is a tutorial. So if you're starting from scratch, totally recommend you work through the tutorial. I think you found one little bug where we actually used to include all of the connectors. Now we have like a leaner distribution, so you have to actually install the Jython processor. So hopefully that'll get updated in the documentation very soon. But I would totally recommend you work through the tutorial. You'll build this pipeline to process credit cards and check their card type and mask them and so on. That'll give you a really good idea of how it works. And then, like when I was building this, it took me less than half a day to get all of this working, and that was mostly playing around with the Cypher query. If you're coming to this cold, it would probably take you a bit longer. But I mean, the thing that makes this really, really fast is if you've got an idea of Salesforce, then this kind of query is this isn't complex. And the thing that makes it really nice is this preview mode, because it means that even if I hadn't put that the Neo4j connector on, I can just preview the data, and I can get my head around what I'm getting back, and I can tweak the query if I'm not getting what I expected, and so on. It makes it quite productive. It's effectively a development environment for these things.
So if you wanted to, could you make your Salesforce query just do a select star so that you could see all the fields that were available from there? Would that be
an
exploratory bit of?
Yeah, and this is fun because this is something that Salesforce itself doesn't natively support. But what I'm doing is I'm doing a metadata query to get all the fields that are visible to you.
Oh, cool. Okay.
And substituting them in. So for whatever reason, Salesforce never put select star in the SOQL language. But yeah, so that's exactly what we've got here. So I can see, is this support case a violation of their SLA? And luckily it isn't. And I've got all the time and date information there, and I can see the types that they come back as. So I can see this is Boolean, this is a date time. So yeah, you can get pretty intimate with the data this way, very, very easily. And also the nice thing is if I put in, so let's just come out of there. So if I delete this guy, this demo is never going to work again. And then if I put in, say, field remover, okay, so that I decide, okay, for whatever reason, I want to remove a field from the thing. This is pretty clever because, it's going to do it. Oh, there we go. So it auto completes because I've done that preview. It's kind of remembered the fields that it saw, so I don't have to type these out. And these nice. Salesforce ones are pretty tricky because that's actually 2 underscores, that $C suffix.
Yeah, you never remember that.
Right, exactly. I mean, well, I did Salesforce for 5.5 years, so it's got $C just rolls off my tongue.
So but you never remember that unless you're Pat.
Right. It's just one of those Salesforce-isms. It just means it's a custom field in the schema. So, yeah, it is like, you know, a productive IDE for building these things. It kind of tries to do the smart thing and help you along without getting in your way too much.
Cool. And then we've got one other question, which I think I will try and interpret what it means. So the question is, can you also use this tool to change data structure transformations? And then this is about ontology. So I'm assuming that would be maybe an ontology that's in maybe an existing database and you want to change it into that existing database.
Yeah, so let me actually find a blog post. I think I've wrote a blog post that I think answers that question pretty well, and it's just in the last few. Oh, there's the Neo4j one, calling external libraries, custom functions, custom origins. Excuse me, here it's a little older than I remembered. Transform data, there we go. So a lot of people, a lot of developers in particular, go straight for the script evaluators and skip over these processors. But you can do things like, here we've got, we're doing a query and we're getting this results back where we've got an array of objects. So, you know, conceptually, this is one record with an array of these result objects. And this field pivoter lets us say, okay, whatever's in results, make that into new records. So you get like one record in with two of these like sub objects, and you get two records out. So I think that's this kind of idea of changing the structure of the data, and then things like you can flatten it out. So here I've got this hierarchy of record with address and street and so on. And I can just say flatten that out so it's just address.street. And then I can rename them because I don't want it to say address. I just want it to say street or whatever. And then I can split the street into street number and street name on the space. So yeah, there's a whole toolbox of processes here for manipulating the structure. And you know, in every case at runtime, it's faster if you configure these things. They're running like in you know, compiled Java, so it's faster than if you wrote a script in Python or Groovy or something to do the same manipulation.
Cool.
As a test, I coded up the same functionality, and it processed only 80% of the throughput in Groovy, even though conceptually it was I was rolling everything into one kind of loop. Even doing these 1, 2, 3, 4 different operations in a row was faster with them broken out like this and easier to maintain. Cool.
I reckon we're pretty much at the end of our hour now. So
okay.
I think you've answered all the questions that we've had. So I guess we can probably wrap up. So thanks, Pat. Michael had to drop off, but he said to pass on his thanks to you for coming on the meetup and showing us all the stuff you've done. And I guess so if people want to go and play with StreamSets, it's just on the StreamSets website, isn't it?
Yeah, go to streamsets.com/open source, and it's free for download. Like I said, it's Apache 2 license, so you can take it. We've got if you go to streamsets.com/community. I don't know why I stopped sharing my screen here, actually. Yeah, let me just show people here. So streamsets.com/open source. So that's where you would download it, and the basics of is it sharing my screen?
Not at the moment, but I've pasted the link in. I can put it in the comments.
Okay. Well. It's decided it's not going to cooperate. Yeah, so streamsets.com/open source, and then streamsets.com/community is where you can get to our Slack channel and our Google group. And yeah, we've got a good community with quite a few hundred data engineers, data scientists, developers now.
Cool. All right, sounds good.
All right.
Great. Thanks everyone for joining, and thanks again, Pat.
Oh, thank you very much. It's been a pleasure.
Cool. Bye, everyone.
Right. Bye.